Hey guys, welcome to College Made Simple, and in today's video, I'm going to teach you how to find the number of significant figures, or Sig-figs for short, in a given number by following three simple rules. Rule number 1, the always rule, what's always going to be significant. Rule number 2, what's never going to be significant. And rule number 3, what's only going to be significant if ... After that, I'll show you how many sig-figs to place in your answer for addition and subtraction equations versus for multiplication and division equations. Now let's get right into it. The first rule in determining the number of sig-figs is that all non-zero numbers, numbers 1 through 9, and any zeros in between non-zero numbers are always going to be significant. Now say your teacher asks you how many sig-figs are in the number 304. What would you say? If you said 3, that's correct. The 3 and the 4 are both significant because they're non-zero numbers, and the 0 in between them is significant because it's in between them. Let's try one more. How many sig-figs does 8,006,033 have? The correct answer is 7. The 8, 6, 3, and 3 are significant because they're non-zero numbers, and the 3 zeros are also significant because they're in between non-zero numbers. The next rule is that all zeros preceding a number are never significant. So in the number 0.0038, how many sig-figs are there? There's only 2. The 3 and the 8 are significant because they're non-zero numbers, and the 3 zeros preceding the number are not significant because zeros before a number are never significant. How about 0.0306? How many sig-figs does this number have? If you got 3, that's exactly right. The 3 and the 6 are significant, as well as the 0 in between them, because of rule number 1, that all non-zero numbers and zeros in between them are significant, but the 2 preceding zeros are not significant because preceding zeros are never significant. The third and final rule is that zeros at the end of a number are only going to be significant if the number contains a decimal. If the number does not have a decimal, the zeros are not significant. So if I were to ask you how many sig-figs are in 3.00, you should say that there are 3. The 3 is significant because all non-zero numbers are always significant, rule number 1, and because of the decimal, the zeros at the end are also significant, rule number 3. How about the number 300? How many sig-figs does it have? Well, the 3 is significant because it's non-zero, but the last 2 zeros are not significant because this number, unlike 3.00, has no decimal. Now let's do a quick recap of the 3 rules before we go on. Rule number 1 is that all non-zeros and the zeros in between them are always going to be significant. Rule number 2 is that zeros in the beginning of a number are never significant. And rule number 3 is that zeros at the end of a number are only going to be significant if there's a decimal. Now let's do a couple of cumulative examples. I recommend you pause the video and try to figure out the number of sig-figs on your own, and then check back to see if you got them right. Okay, here's the first one. How many sig-figs does the number 0.0840200 have? Now let's walk through all the rules. The first rule is that all non-zero numbers and the zeros in between them are always going to be significant. So that takes care of the 8, the 4, the 2, and the 0 in between the 4 and the 2. Now rule number 2 is that the zeros in the beginning of a number are never significant. So let's cross out the first 2 zeros. And rule number 3 is that the zeros at the end of a number are only going to be significant if there's a decimal. And as we can see, this number does contain a decimal, so the last 2 zeros are also significant, bringing the total number of sig-figs to 6. Alright, one more. How many sig-figs are in 0.34020? The 3, 4, 2, and 0 squashed between them are significant because of rule number 1. The first 0 is not significant because of rule number 2, and because there's a decimal, the final 0 is also going to be significant. So the total number of sig-figs is 5. Now one of the reasons for knowing the number of sig-figs is to know how many sig-figs to place in the answer to an equation. Now there are two different rules for how many sig-figs go into your answer. One rule for addition and subtraction, and another for multiplication and division. For addition and subtraction, you need to round your answer to the place of the least precise sig-fig. Now I know this might sound a bit confusing, but once you see how it's done, it should make a lot more sense. I'm going to walk through an example. Let's say we have 1,300 plus 16 plus 208. The first thing I'm going to do is line them up in their correct place, and then look for the least precise place. In our case over here, it's the hundreds place because of the number 1,300. This number is only precise until the hundreds place, 300. Now I'm going to make a line all the way through where the answer will be, and all the numbers to the left of the line will be significant. But remember that the first number to the left of that line needs to be rounded either up or stay the same. If the first number to the right of the line is 5 or higher, we round it up. If it's 4 or lower, it remains as it is. Now let's add everything up. 6 plus 8 is 14, 1 plus 1 is 2, 3 plus 2 is 5, and bring down the 1. So the number we have is 1,524. Once we have this number, because the least precise digit place is the hundreds place because of the 3 in 1300, we need to round the 5, which is in the hundreds place, either up or leave it as is. And because the number to the right of it is less than 5, we leave it as is and change the last two numbers to zeros. So the final answer with the correct number of sig-figs is 1,500. For multiplication and division, however, things are slightly different. Here you need to round your answer to the same amount of sig-figs as the term in the equation with the fewest number of sig-figs. Let's do an example. Say we have 283 times 17. Let's plug it into a calculator, and you should get 4,811. But we're looking for the correct number of sig-figs, and to do that, we need to look at the numbers in the equation, and how many sig-figs each of them has. 283 has 3 sig-figs, and 17 only has 2. So our answer needs to be written with 2 sig-figs. So we take the 4 and the 8, and then look at the number next to the 8 to see whether we keep it as 8 or make it 9. And since it's less than 5, we keep it as 8. So the correct answer in terms of sig-figs is 4,800. Now for a quick recap of everything we covered in today's video. The 3 rules in determining how many sig-figs are in a given number. Rule number 1 is that all non-zero numbers and zeros in between them are always going to be significant. Rule number 2 is that zeros in the beginning of a number are never ever going to be significant. And rule number 3, zeros at the end of a number are only going to be significant if the number contains a decimal. Then, to determine how many sig-figs to place in your answer to an equation, it depends on the type of the equation. For addition and subtraction, line up all the numbers and round your answer to the least precise sig-fig. And for multiplication and division, round your answer to the same number of sig-figs as the term in the equation with the least number of sig-figs. Thank you so much for watching. If you enjoyed the video and found it helpful, please consider hitting the like and subscribe buttons. If you have any questions or tips for how I can make the videos better, please let me know in the comments section down below. Have a great day, keep learning, and peace out.